All right. A couple more little points or tricks that we can get from quadratic equations. And you'll know that you'll notice we put lots of emphasis on this. And there seems to be always just another little tidbit or another rule or another tool that you can use to help you describe quadratic equations or quadratic functions. In this Scribblecast, we'll be looking at three things. Determining first the nature of the solutions of a quadratic equation. Then we'll look at, once I know the maybe some x-intercepts or solutions, seeing if I can go backwards and find the quadratic equation. And then lastly, we'll solve some equations that are quadratic in form, but they may not look exactly like a quadratic equation. So the first thing we'll talk about is something called a discriminant. Turns out that when I have a quadratic equation, or when I look at the graph of it, there's three different possible results that could happen. I could have a quadratic graph or parabola that goes through the x-axis twice. If it goes through the x-axis twice, I'm going to get two solutions. Maybe I should write that over here. I'm going to get two solutions for that graph. And the two solutions are real number solutions. Now, I know that this happens if, when I'm looking at the quadratic formula, whatever happens underneath that square root sign, if it's positive, I know I'm going to get two solutions. Now, if it's negative, if whatever comes up underneath there is negative, taking the square root of a negative, I know on the real numbers there would be no answer. But if it's negative, I can look at complex answers. And so in this case, I would have no real solutions. However, I'd have two imaginary or complex solutions. Okay, and notice that the graph of that one comes and it doesn't cross the x-axis. So any x-intercepts, of course, would be imaginary because this graph doesn't even cross it. The third solution that could happen is if underneath the square root sign here, I come out to a number that's equal exactly to 0. So if this discriminant, that's what they call it, if this discriminant comes out exactly to 0, then I'll have one real number solution. And the one answer will be wherever that graph just touches the x-axis. So that's called the discriminant, and sometimes that's helpful to be able to determine the kinds of solutions that you get. If it crosses twice, it means the discriminant is positive. You'll have two answers. If the graph doesn't cross, that means that underneath here, I would have got a negative number, or it's less than 0, so I would have no real number solutions, but I'd have two complex ones. And if what happens underneath the square root sign comes out exactly to 0, then I'm going to have one real solution, and graphically that would just touch at one spot on the graph. Okay, now let's turn our attention to something like Jeopardy. You know, in Jeopardy they give you the answer and you have to give them the question. In this case, or in this concept, what we want to do is, if I'm given the answers to a quadratic equation, the question is, what was the equation in the first place? So they say in this, here that the solutions to a quadratic equation are minus 2 and 2/3. What was the original equation? Well, that might be a little bit tricky, but let me try an easy one and see if we can work into that. So say I had the equation x squared plus 6x plus 8 is equal to 0. Say that was my equation. To solve it, I decided to factor. So I got x plus 4, x plus 2. Then I said zero property, x plus 4 is equal to 0, or x plus 2 is equal to 0. And then my solutions were x equals a minus 4 or x is equal to a minus 2. Now the relationship I want you to see is from here to there to there. So if I came up with an answer of minus 2, it means that I must have had x plus 2 is equal to 0, and one of the factors must have been x plus 2. An answer is minus 2, a factor must be x plus 2. Notice I just changed the sign there. If an answer was minus 4, a factor must be x plus 4. So let's try our question here. It says one of the answers to a quadratic equation are minus 2. That must mean that one of the factors was, hopefully you said to yourself, x plus 2. And similarly with the other one, here it was a positive 2/3, so my factor must be x minus 2/3 is equal to 0. So this would be the factored form of my original quadratic equation. But they probably want me to FOIL that all out. So why don't we do that? So let's FOIL. So x squared minus 2/3 x plus 2x minus 4/3 is equal to 0. I look at it and I say, fractions are ugly. Let's use the I hate fraction rule and just multiply the whole thing by 3. That's the lowest common denominator. So it'll be 3x squared. 3 times this would just be minus 2x. Times this by 3, it'd be 6x. Times this by 3, it'd be minus 4. Simplifying, I'd get 3x squared plus 4x minus 4 is equal to 0. This then would be my original quadratic equation for a minus 2 and 2/3 solutions. Okay, so it's sort of working backwards. Okay, sometimes the answers, like we've seen, would be complex numbers. And so if they have something like this, they say the solutions to a quadratic equation are minus 3i and 3i. Notice they always come in pairs, the complex ones. What was the original equation? I can do the same thing. From minus 3i, I would get a factor of x plus 3i. And from plus 3i, I'd get a factor of x minus 3i. You seeing how that works? Now, FOIL, x squared minus 3ix plus 3ix minus 9i squared. If you FOIL that all out, these two middle ones cancel, leaving me with x squared minus 9, I squared was minus 1, right? So I'd get x squared plus 9 is equal to 0. And that would be my original equation that gives me those two solutions. Just sort of to push the point a little bit there, if I were wanting to take this equation x squared plus 9 equals 0 and solve it, an easy way to do it would be to take the 9 to the other side. It'd become negative, and then use the principle of square roots. So I'd get x is equal to the plus or minus square root of negative 9. Then, plus or minus, square root of negative would be square root of negative 1 times the square root of 9. You see where I'm going here? Plus or minus, the square root of negative 1 would be an I. Square root of 9 would be a 3. So that's where, like what I did is I just solved that equation. But that's where they would have got the plus and minus 3i originally. Okay, now let's turn our attention to looking at quadratic equations in that form, or something that has that kind of form to it. For example, I've got an equation here. X to the 4th minus 9x squared plus 8 equals 0. It looks very much like a quadratic, but it's got a 4 there. So what we can do is we can, and this is one strategy, and I've used this before in another session, I think, in the class, is if I don't like dealing with this kind of thing, although I can see that it's sort of a quadratic, if I don't like using the 4, what I can do is do something like this, where u is equal to x squared. So every time I see an x squared, I can replace it with a u. So here I have x to the 4th, which is really x squared times x squared. minus 9x squared plus 8 equals 0. Everywhere I see an x squared, now I'm going to replace it with a u. So here's an x squared, that's a u. There's another x squared, so that's another u, or u squared. Minus 9, okay, x squared we said is a u, plus 8 is equal to 0. Now I've got one that is quadratic. This is a quadratic equation which I can solve. And it looks like I can solve this one by factoring. Hopefully you're getting very comfortable with factoring. We seem to have done a ton of it already. I think that's the right answer for that. And so to solve the equation, I would now say u minus 8 is equal to 0, or u minus 1 is equal to 0. Or in other words, u is equal to 8 and u is equal to 1. Feeling pretty good at this point, I'll look back and say, oh, hold it. They were wanting me to solve for x. Well, here I see that u is equal to x squared, so now I'm going to replace, anytime I see a u, I'm going to replace it with an x squared. So I'm sort of going to go backward. So instead of u there, it's going to be x squared is equal to 8. Instead of u here, it's going to be x squared is equal to 1. And notice here I've got quadratic equation again that I can solve by the principle of square roots. I'll square root both sides, making sure I put my plus or minus on this one. Square root both sides, again making sure I put a plus or minus there. Okay, so my answers then are plus and minus 1 and plus and minus root 8. One thing with the root 8, and this is a little thing, but if I can get a perfect square that'll divide evenly into this, I should simplify that. So 8 is the same thing as the root of 4 times root of 2, and the square root of 4 is 2 root 2. So really my answers are x is equal to plus or minus 2 root 2 and plus or minus 1. Notice in here I get 4 answers to this particular question. Using a similar idea, I can solve more complicated ones. And I'll give a framework for this one. You can finish it if you want. But here I've got something squared minus 14 times that same something plus 24. So I can do my little trick and say, hey, let's let u equal x squared minus x. So everywhere I see x squared minus x, I can replace it with a u. So this whole ugly looking thing becomes u squared minus 14u plus 24 is equal to f of x. In this case, they want us to find the x-intercepts. To do that, I need to plug a 0 in for the f of x. And now I'm going to endeavor to solve this equation here. Let's hope that it'll factor. Okay, I'm looking for two numbers that multiply to 24 and add to 14. 6 and 4, 12 and 2. So u minus 12 and u minus 2. U squared minus 2 minus 12, yeah, it's minus 14 plus 24. Yeah, that works. So I would get 0 property again here. U minus 12 is equal to 0, or u minus 2 is equal to 0. Therefore, u is equal to 12, or u is equal to 2. Again, looking back, they don't want u, they want an x. So I'm going to have to replace that u with x squared minus x. So instead of u, it's going to be x squared minus x is equal to 12. Or x squared minus x is equal to 2. Oh my goodness, now I've got two more quadratic equations to solve. So I have x squared minus x, bring the 12 over to this side, it'll be a minus. Now I'm going to have to solve this. X squared minus x minus 2 equals 0. Now I have to solve that as well. I think they both can factor. Nice that they gave us a question like that. X minus 4, x plus 3, x squared plus, yeah, that's right, And over here, x minus 2, x plus 1. Check that, x squared plus x minus 2x, yeah, that's a minus 1. and minus 2. That's right. So here my x is going to be equal to 4 and negative 3. Over here my x is going to be equal to 2 and a negative 1. So in this case, again, I get 4 answers, all of which I should be able to plug in to that original equation. And you can try this if you want to check. Plug them into the original equation, and I should be able to, I guess I should plug them into, yeah, this original equation, and I should come up with 0 on the left-hand side. So all of this stuff here should come out to be equal to 0. So it gives you a couple more bits of exposure to some quadratic equations, a couple other tools or tricks that you can use to help you determine characteristics of these quadratic equations. Try some questions.